sir.
Both are different algorithm. Hello.
Start recording, sir.
Both are different algorithm. KNN is a classification algorithm, and K-means is a clustering algorithm. Okay, so don't be confused whenever you will say K. So don't be confused whenever you are in hurry. So such mistakes you are generally doing, we have observed in your exam paper, right? So let's start again KNN in detail. So here KNN means K nearest neighbor classification, and of course you can see it's a classification algorithm. That means we would be having some of the data as a feature attribute, and one of the column, okay, one of the column as a target attribute. Now here it depends. The target attribute may be two types of target attribute, as we have discussed in the previous lecture. That one is a categorical, or you can say discrete. Right, discrete means any 2 or 3 or 4 which you can calculate in a numbers, okay, quantify, okay, in a numbers, right? That is a discrete. Medical data, right? Suppose you can see the COVID-19 infection rate, right? If you'll see the report, so that would be, that is a number, maybe 20 city value, or maybe 21, 30, 34. So that would be in a range. So if the city value within this range, that is a COVID positive, otherwise not, right? So if it is in a range, so you can consider like maybe a range of, like, you consider 10 to 30. So all the points occurred between 10 to 30 you can consider as it is in a range. So if the given attribute that is in a range, so you can say it is a regression model, and you can also solve this regression model using KNN. So KNN can be used with a target attribute if it is a discrete and if it is a continuous. So in both of the case, KNN can be utilized. So how it is going to be utilized, we'll see, okay, with one numerical. So let us start. Let us start the algorithm. So here you can see there are three pretty simple steps, but we'll understand these three pretty simple with one of the pictorial examples, so that at least you can understand very well. So here what you need to focus here, that what you need to focus, that these things, okay, so these are some inputs, right? Whenever your algorithm starts, it is a pseudocode, and this is the input. D means your whole data set, small d means your unknown sample, okay, and K means your the input parameter. So what is D, small d, and K, we'll see, right, with one of the example. So before going in this pictorial example, this one, at least read these three steps. At least read these three steps, okay. For just one, compute the distance between D and every example in D, right? So here we need to calculate the distance. Choose the K. Some K needs to be drawn that are nearest to D, and assign D the class that is most frequent in P. So what it means, we'll see. So let us start with this example. So here. So here you have here you have a three class, 1, 2, and 3. Name is government, that is in a green, science, that is in a red, arts, that is in a black, right? Government, science, and arts. Okay. Now here, whenever you see this data, and of course you can see now that this data is a drawn kind of scatter plot, right? And you want to classify these three class. So it is a multi-class problem, because here there is only here more than 2 class. So you can also say it is a multi-class problem, right? So how can we solve using the KNN? So we'll see the previous algorithm, right? This one. And we'll start with the first one. What is the first one? That compute the distance D and every example in D. What it means. So let us see. let's see that one of the new point coming into the picture, one of the new points, so this one, okay, one of the new point coming into the picture, and you want to find that this new point falls under which category, okay, that is your objective or that is your question. So maybe this falls under arts, maybe science, or maybe government. So how can we classify that this unseen sample, or okay, or you can say the test sample will follow which category? Green, red, or black? Okay, so green is government, red is science, and black is arts. Okay, so how can we conclude? Okay, so this is what our objective. Now let's start with the first step. That you need to define capital D and small d first. So small d means this is a new sample. You can represent this is a D, and capital D means your whole data set. Capital D means your whole data set. And how many samples are available? Let's calculate. These are 3, 6, and 8. This is 8. This is 6, and this is 4. So total 6 plus 4 and 8. So total 18. So total 18 samples are there, right? Okay. Now let's see what is mentioned in first statement. Compute the distance between new sample and every example given in a D. So how can we represent this thing in mathematically? So can we write like this way? So you want to find the distance, right, from unseen sample, that is a D, comma, every sample of given database DI, and here I is equal to 1 to 18. Okay, I is equal to 1 to 18. So this is how you can conclude the first statement in a mathematically. So ultimately you want to find the distance D between DI. Now the another question arises that distance, then definitely you have in your mind which kind of distance. So for the same you have a two distance equation. One is a Euclidean, another one is a Manhattan. Okay, so what is the equation for the same? Euclidean means, of course, it is very easy. Under root of x1 minus x2 whole square plus y1 minus y2 whole square. So this is Euclidean distance between 2 points, right? If it is Manhattan, then Manhattan can be calculated as a mode x1 minus x2 plus mode y1 minus y2. So this is x1 minus x2 plus y1 minus y2. So okay. So this is the Manhattan distance, Manhattan distance, and this is Euclidean distance. This is how you can find the distance. Okay. So let us see now the second step. Choose the k example. So this is something new. K examples in a D that are nearest to D and denote set P belongs to D. What it means? So here K comes in the picture. So K is one of the hyperparameter which is user defined. Okay, so that is given in your exam. So how much value of K? So in this case, the K is equal to 6 has been considered. You can see over here, right? Okay. Now what is the meaning of K? Meaning of K is the number of points which are going to select, okay, from the unseen sample which is nearest, right? So let us see that what is the meaning of 6 over here. So you have this unseen sample, okay, you have this unseen sample, right? From this unseen sample you already measured the distance from the first step number 1. So you have calculated the distance, okay, from each point, all 18 points, okay. From all 18 points. Now from this point, which are the 6 points which are close to each other? Okay, which are close to each other. Okay, 6 points only, because which you have selected, K is equal to 6. So that's why 6 nearest point from this unseen sample. And these are the 6 points. You can say 1, 2, 3, 4, 5, 6. Right? Now, once you selected the 6 closest problem, the closest point, now another, that is the third step. The third step is assign D, the class. That is your goal, right? You want to identify the class of the unseen sample. Which class you are going to assign? That is the most frequent class in a P. So now if the P means, here the P means P is equal to, how many greens are there in this 1, 2, 3, 4, 5. 5 greens, okay, and 1 red, right? Can you write like this way? P is equal to, okay. Now, which one is the most frequent? Here you can see the word is the most frequent class in P. So 5G and 1R. So which one is the most frequent? This one is the most frequent, okay, compared to this one. So now you can conclude that this unseen sample is going to fall under government category. Okay, so this is going to fall under government category, right? Because the maximum points in a given radius, okay, given radius means how, which are the closest 6 points, okay, that is the number of K. So it may possible, okay, here the example is over and algorithm is also over, right? Now let me change one thing. Suppose I am going to change the K equal to, suppose I am going to change here K is equal to, instead of 6, K is equal to, so here you can see unseen sample, this one, here. So here you have unseen sample. K is equal to only 3. So which are the closest 3 points? So you can see this one, right? And we are, how many total points? There are 3, and out of these 3, 2 are green and 1 is red. So maximum is what? Green. So that's why this point again falls under green category, right? For example, let me give another example. So here you have one more point, maybe over here, okay, and it is said that K equal to 2 only. K is equal to 2. So you can see, so these 2 points can be considered, okay. Now here there is a tie, 1 R and 1 black. So that means R means 1 science and 1 arts. So in which class you should follow? Okay, so that is up to you, because here it is a tie. So whether you want to give it a label as a science or arts, okay, so there is a choice, okay, that is up to you, and both answer is the correct answer when there is a tie, right? But let me consider that K equal to, instead of 2, K equal to 3. So at the same time you have to consider this one as well, and now you have, instead of 1B you have a 2B. So this point is going to fall under arts category. Okay, so this is how you can control. Okay, so it is very pretty simple algorithm, and there are a lot of application for the KN algorithm when there is, the number of samples are less and you want to predict from the instantaneous, right? So no need to train much more, and no need to wait for the training model. And here there is no such kind of training is provided. It is just a mathematical calculation that we are doing, right? So in this such case we can apply. So maybe generally, this one is very old algorithm, and till so far majorly it is used in recommendation. Then it is used in the classification, okay, of you can say digit classification, where having only 10 digits, 0 to 9, right? So in such case maybe number plate, or you can say the license plate classification, okay. So at those times you can think about it, right? So such kind of application you can utilize. So here you have this KN algorithm. So let me show the example. Okay, so here here you have a one more example. So from the pictorial steps we have gone through, so let us go with a real life example, okay, which is going to be considered as an exam point of view. So here we have data from the questionnaire survey and objective testing with two attributes. So two attributes are x1 and x2. X1 means acid durability in seconds and x2 means strength kg per square meter. To classify whether a special paper tissue, so here a paper tissue is good or not, so good or bad. Okay, so here only binary classification, and there are 4 training examples are given. So you can consider that x1 and x2 are the feature attributes and y is a categorical attribute, or you can say the target attribute. Okay, so target means where the labels are given. So here you can see there are only 2 labels, bad and good. So that means you can say it is a discrete. So if it is discrete, so that you can say it is a classification problem, not a regression problem. So in contrast, regression problem means you can see this one. So here you have a height and age and weight, and the question mark is over here. So you have some 11 sample up to 1 to 10 data. Up to 1 to 10 data you have the data set you need to consider, and 11th sample is an unknown sample or unseen sample. If the height is 5.5 and age equal to 38, then what will be the weight? So this is the question, right? Now, if you are considering this weight as a target attribute, so here you can look at, so none of the the fixed values are over here. So you cannot see like the fixed values. So instead of that, it is some kind of range, right? Which is a numerical continuous range. So that this data set you can consider as a regression, okay, not a classification. So this is the main difference. Okay, so before looking into the KNN algorithm, you should aware that this KNN algorithm, for this data set, KNN algorithm can be solved using the regression, and for such kind of data set where the category or discrete variables are there, at the same time you need to do the classification, because in exam it is not going to say you that you have to use regression or classification. Okay, so please keep this in your mind. Okay, so this is your test from the data set, what you understand, regression or classification, right? Now let us start with first classification, as we have already gone through in pictorial way. That is a classification problem. Three discrete values we have seen, right? So let us see here x1 and x2. Here 7 7 this bad, 7 4 this bad, 3 4 good, 1 4 good. So let us see what is the question now. Now the factory produces a new paper tissue that passed laboratory test with x1 equal to 3 and x2 equal to 7. So that means a new sample is going to come with x1 equal to 3 and x2 equal to 7 without another expensive survey. So you can see this is an advantage of the machine learning. Without another expensive survey, can we guess what the classification of the new tissue? New tissue. So here we have a question mark. Here we have a question mark, right? So x1 equal to 3, x2 equal to 7, and here we have a question mark. So this is what we want to classify. Here, this is what we want to classify. Okay. So how can we do with KNN algorithm? So we'll apply the same steps. So we have already gone through the PPT. So the PPT we have gone through, the first step, the from unknown sample to the every examples. So here unknown sample is what? 3 and 7, right? 3 and 7. So first of all, we need to calculate the distance, and I'm saying that you can use the Euclidean distance. So what you can do, and first for the first one you need to do that 3 and 7 and 7 and 7. So under root 3 minus 7 whole square plus 7 minus 7 whole square, right? For the second one, can anyone reply what is going to be there? Under root of, what would be the answer? Bolo? Dev Patel? Dev Patel? Dev Patel is not here. Hello. Manthan Patel. Those who are present here, please write in the chat box. Yes, Manthan. Yes, sir. Okay. So, Manthan, tell me what should be the answer over here. You can unmute your mic and speak. So, here we have 3 and 7 unseen sample. So, how can we calculate the Euclid distance for these samples? What is going to be there? 3 minus 7 whole square plus 7 minus 4 whole square. Right? So this is the answer. And similarly for 3 minus 3 whole square, 4 minus 7 whole square, or 3 minus 1 and 4 7 minus 1. So this is how you can calculate the distance, and here it is given. Okay, and here you can observe. So some of the answer is like 16, 25, 9 and 13. Okay. So you can also do the under root of it. It is fine. It is up to you. Whether you do or not, but ultimately you need to just compare the distance, so it's up to you that whether you are calculating or not. So if you are not going to do so, which is going to be fast, because square root is directly proportional to the answer. Okay, so that's fine. So here you have, now once you found the distance, you need a k, because you can say choose the key examples in the data set which is nearest. So here how much k is considered? In this case k equal to 3. In this case k equal to 3, and we need to choose as k equal to 3, we need to choose the least 3 values. So least 3 value means this one is the minimum, then it is the first, this is second, and the last 3 is equal to 3, the third one. So these 3 values have been selected, right? This one, and this one. Now once this is done, then third answer is assign the D class, that is most frequent class. So which one is the most frequent class over here from 1, 2 and 3? So let's check 1, 3 and 4. Okay, so it's the row number 1, row number 3 and row number 4. So which were the class there? Let us see. The class are bad, good, good. So here the class are for this one, it is a bad, it is a good, and it is a good. So which one is the majority? Most frequent is what? Good. So what you can do, this unknown sample, if 3 and 7, which will classify as good. This is what your conclusion, right? So this is how here it is solved. You can see here you cannot consider because it is maximum 1, 2 and 3. So 3 need to consider. So these 3 are bad, good, good. Which one is the most frequent? Good. So answer is going to be included in the good category. So this new sample is going to include it in the good category as per the KNN algorithm. So this is how you can solve this KNN. Very simple algorithm, no complex calculation, and it is a score driven, this question. Now the another type of question, the previous question we have seen the classification, now regression. So you have to follow the step number 1 and step number 2 are same, nothing changed, but step number 3 you have changed. So step number 1 is what? To calculate the distance for unseen sample to the non-sample, right? So distance is, you can see this one 5.5 to 38. So what it means, we need to do 5.5 minus 5 whole square plus 38 minus 45 whole square. So that would be the distance for this row. Then 5.5 minus 5.11 whole square plus 38 minus 26 whole square of under root. Okay, so that would be the answer of the second row. Similarly, you will do for all 10. Okay, similarly you will do for all 10. The second step was to find the k minimum value. So here, how much k is been considered? Let us see. So for easy understanding, is that it has been drawn in a pictorial way. But in your exam, don't draw in a pictorial way. Just calculate the distance as we have calculated over here. Right here, how we have calculated over here. Okay, in pictorial, it is not necessary that you will get the correct answer because you do not have the graph paper. Okay, and in real sense as well, we are not supposed to rely on a graph, but instead of that, we in a computer, whenever we make an algorithm, this algorithm, you require the mathematical computation. Okay, so never use graph in your exam. So here, how much k is being considered? K equal to 3 is being considered. And once you found the distance, then you can see which one is the closest one. 1, 5 and 6 samples are closest one as per the distance, 1, 5 and 6. So if 1, 5 and 6, Then step number 3 was in the previous slide. So you can see assign the D class, but here there is no class. Okay, so we need to consider the most frequent, but here something different. Instead of D class, what we are going to do, the most frequent, which are the falls under the nearest one, that is 1, 5 and 6. We are going to pick those rows. So here which one? 1, 5 and 6. So let me make a mark over here, 1, 5 and 6. So what is the value of 1? That is 77. What is the value of 5? That is 72. What is the value of 60? That is a 6, that is 60. So in order to find this answer, you need to do the very simple step in a third step in a regression problem. You just do this mean of the selected points divided by 3. So you will get 66 point. You will get 69.66 kg. You can see over here. Okay, so let's look at in very good way. So here you can see you selected 1, 5 and 6 point. This height and age. So you just pick the weight value in the given column of the selected points, 77, 72 and 60. And how many points are there? 3. So this divided by 3. So ultimately you are finding a mean of that. So the answer is 69.66 kg. So this is how you can also solve the regression problem using KNN, right? So you can see now that the logistic regression problem can only solve the binary classification problem. Logistic regression cannot solve the regression problem. Whereas in KNN can be solved, the same algorithm can be useful in a two-way, right? So KNN can be useful in a classification, KNN can also be useful in a regression. Okay, so please keep this in your mind. So you must aware. Now the little change is what, suppose if you are going to change the value of k, at the same time answer is also going to be changed. You can see over here 65.2, because at the same time you are supposed to select 5 points. So you can say that k nearest neighbor algorithm is highly dependent on the constant k, which is the user defined, right? So k nearest neighbor. So this is how you can solve the k nearest neighbor. So there are some strength and weakness. So strength I told earlier that it is very simple algorithm. It is very simple algorithm. Then no much complex, the training part, right? No much complex mathematical equation. Is it easy to understand? Okay, so that means it is simplicity. Though it is a simply and easy to understand, but it has a major drawback, and that drawback is, as we are not providing a training, so whenever your unseen sample is going to come, whenever there is an unseen sample is going to come, whether it is one unseen sample or 5 unseen sample, each and every unseen sample we need to calculate for whole data, because as the step number 1, what is the saying? Compute the distance between unseen sample and every example in D. So how many unseen sample? Let's assume that there are 10 unseen sample is coming. Okay, and you have 1000 points that is given in a data set. So in total you have to access 10,000 points, which is pretty the slow algorithm. Okay, so you can see the slow at execution time. Classification time is very slow, right? Whereas in other algorithm, you consider the linear regression. You have already gone through the linear regression, right? In a linear regression, what happened? You have some sort of like x and y you can consider. Okay, maybe this is the area. This is a house price. This is house price, and maybe some samples are given. Right, so maybe some samples are given, maybe 8 or 10 samples are there, and from these 8 and 10 samples, as you can see in the previous studies, you have solved this equation y equal to b0 plus b1x, y equal to b0 plus b1x, and once you found this answer of b0 and b1, so you can write like b0 is equal to 4. Let us write 4 plus 2x, right? So once this equation is prepared, at the same time, as many unknown sample are going to be there, you just need to put over here, replace with x, and you can predict the y, right? So area is, suppose there is a 2000 square feet. What would be the price 2029 square feet, what would be the price? 2080 square feet, what would be the price? So for all the values, you are not supposed to go through with each and every point given in your data. Whereas in KNN you need to do, because this algorithm is saying, right? So that's why this is a slow, and the drawback is, when you have a lot of amount of data, like you can say 1 lakh points, at the same time it is not advised to use KNN, right? Now in real life, in which case you can say KNN cannot be useful. You consider this COVID-19 third wave. So you have the historical data of COVID-19 first wave and second wave, right? From this historical data, you want to predict the cases for the COVID-19 third wave, right? Now you have the data, maybe a COVID-19 1 and 2 data. You may have a lot of data, but as you can see, in the third wave, not only few cases, but there are a lot of cases coming into the picture. So you just understand that we have 50,000 samples, right? We have 50,000 samples of previous history, COVID-19 1 and 2 case, and now on every day you are getting 200 new cases. Okay, only 200. There are many more today, but only 200 I am considering. So how many calculations required? 5 into 2, 10, and 4 zeros are here. So 1, 2, 3, 4, and 2 zeros are over. You can see how many calculation is required. You can see, right? So it is a lot of, okay, so it is kind of 1 crore. So if you are going to solve such problems using KNN, this will suffer the computation problem. So instead of this KNN, can we have some y equal to mx plus c, a trained model? You just apply 200 values over here and you can directly predict the y. So it is pretty much simple. Okay, so if you want to go with a regression, you use the linear regression. If you want to go with a discrete value, you can go with a logistic regression. You have an option. Okay, so I told the limitation of KNN. Okay, and this phenomena is also lazy learner. So KNN is a lazy learner. Why lazy learner? Because it doesn't provide any training. It accepts all the points while the testing time. So there is no such kind of training. And another drawback is, in algorithm, if you have noticed, what it return every example. So every example, what it means, every example, what I mean to say, let us say there is a 1 green point available over here. Let us say that 1 red point is available over here. Okay, so this is a green point and this is a red point. There is a science. Okay. Now, as per this algorithm, in the first step, what it is written that from unseen sample to every points given in a whole data set. So whether it is outlier, even though you need to consider, even though you need to put into calculation, right? You need to measure this distance. Even though it is outlier, you can see pretty much simple to understand from this visualization that G and R are outlier, but still you need to calculate. Why? Because this algorithm is saying that every point. So this is also one of the more drawback that you can understand. Okay, so this is how you can solve the KNN algorithm, and I told you that limitation and advantage, right? So if you have any query in this algorithm, you can discuss. Okay, now if you do not have any questions, so I have some questions related to some work in machine learning. So one of the pedagogy, as we have discussed about the research paper, so I want to know that how many students have formed a group and have started. So please send me the answer in a chat box. Please send me answer in a chat box. And as I told you in class that I strictly monitor this research work, and it is highly required in your for the recommending students in other university. So I'm not
Sir,
uh,
sir, we have formed a group of three and we have selected a topic, but still, right now we are just going through some papers and information online. We haven't started preparing the paper yet.
started preparing the paper at initial stage. You cannot do unless and until you have problem statement and results, right?
Yes, sir, the problem
First of all,
statement
you
has been
have problem
prepared.
statement, then you have some, how to solve this problem, and you try to run this algorithm, execute some results, make a table or a graph, and then you can start a research paper.
Yes, sir. So we are just going through all that things and figuring out.
Okay, so I'm receiving answer from only one student. Any other students? I am saying very strictly about the recommending the students either in a placement or either in a abroad. Okay, otherwise don't expect a recommendation from my side. This is my one of the condition by for giving a recommendation. You just understand this. If you have any kind of doubt, you can ask me. So it is open platform. But anyhow, you have to do. I'll also take one of the lecture, maybe 30 minutes or 45 minutes, how to write a research paper, how to search as a BTech level, what is the expectation of a conference publication, right? So that at least you can minimize your effort. But I'm still not receiving the answer. So at the same way, like you are keeping mum here, the same way whenever you will come for the recommendation, I'll keep my mouth up. Right? So please keep this my words strictly in your mind. This time I am not going to tolerate such things. That is for 100%. Sure. And I have a list from the TNP committee that how many students want further studies, okay, and how many students want placements. So I have received the entries, whatever you have done. We already discussed in the class when I was in a person, right? I think first or second class. Yes, who was speaking?
Sir, can we get some examples of research papers?
Yes, of course, you can search on Google Scholar, right? So if you want to see, then let me show. So here you have a Google Scholar, right? So let me tell that, like suppose you want to vehicle detection or vehicle number plate detection. So vehicle number plate detection, right? It's very simple, and here you can search for this topic. There are a lot of research papers, and when you can see this is a PDF, that means you can directly download the PDF. And if this is not a PDF, is downloadable. For example, this PDF is not downloadable, right, in IEEE Explorer. So for the same, you just search in a Google SCI-HUB. Okay, so you can download the paper here by putting any DOI. So DOI may be written different at different places in a different journal indexing, maybe IEEE or Springer or elsewhere. Okay, just copy the DOI. You can see here the paper has been, whichever are the free, like PDF copy. So this PDF copy has been opened. So here you can see this one, right? So here is a conference paper. It is not working. Okay, so paste over here and no problem. Okay, the paper will be opened soon. Maybe you can also download such things like this way if it is not openable. Okay, got it? Drashti?
Yes, sir. And sir, for what are the prerequisites for writing the research papers? Just like you said right now before some time.
The prerequisite is problem statement, whatever the project, how you have completed your SGV projects, the same things you have to complete as soon as possible, maybe 1 month. Okay, 1 or maybe 1.5 months. So that in the remaining 1 month you can write a paper. So whenever you write a paper, at the same time you have a lot of questions that what are supposed to things put in under the introduction session, what are the supposed to put under related work, then methodology is what, results are what. So you should have some problem statement in your hand on which topic you are supposed to work on, which application you are supposed to work, then which methodology you are supposed to apply. Okay, then you can think that which algorithms you are supposed to execute, then represent the results in table and graphs, and then you can think about the research paper, because these all the necessary things are required in a research paper. Okay.
Hello, sir.
Yes.
સર તમે કીધું કે સર 1.5 મંથમાં તમારે પેપર કરવાનું, બટ સર સારા પબ્લિકેશન્સ માટે જવું હોય આપણે, સર એ રિસર્ચ તો મિનિમમ સર એટલીસ્ટ 1 યરની હોવી જોઈએ ને સર. પછી હું એટલે સર 1.5 મહિનામાં રિસર્ચ પતાવું તો સર એવું એની સર કઈ રીતે એટલે મારે સારા પબ્લિકેશનમાં પછી પબ્લિશ કરવું સર?
So that is up to you. That what I said as a confirm, I am expecting conference paper. If you want to go beyond that, that is open to you. That instead of a EEE conference or Springer conference, if you want to publish your paper in elsewhere or the MDPA or any open indexing journals, so it is most welcome. Of course, you are right in such case, right? But at least I can expect a conference paper as one of the pedagogy, okay, and as one of the requirement, okay, in a recommendation. Conference paper can be published, and so many my previous students have from your class even, or not your class but your seniors, okay, your seniors have been published. Your super senior also have been published, and even I have proof of the same if you want to look at. Okay, so I am expecting minimum conference paper, maximum it is up to students, right?
ઓકે સર. સર બીજી એક વસ્તુ સર પોસિબલ થાય કે અત્યારે જે રિસર્ચ ચાલે છે તો એ સર એ કન્ટિન્યુ સેમ 7 સેમમાં કરી અને ડિટેલ રિસર્ચ કરીને પબ્લિશ કરે સારી પબ્લિકેશન્સમાં?
That is fine. Okay, that is fine. But whenever you are going to make sure this, I'll ask, okay, which are the tasks you have been completed? I am not giving any random recommendation, because I have been gone through what you have said in the previous year. Okay, I have been gone through with the same kind of statements. I know sometimes students feels like we can make a fool of the faculties. So I'll strictly follow my previous experience, and based on that I will take a decision. Whatever, suppose you will say that you require 6 months to complete a very good paper, it's fine, it is up to you. But 6 months gradual efforts needs to be seen, otherwise not. You will be recommended in any case. Any other question?
Sir, what if we can follow this kind of roadmap that first of all in this semester we are targeting the conference paper. Once the conference paper is accepted, after that in 7th sem we can carry on that research, and like Rahul said, we can publish it. So we can publish it in a detailed orientation. So there will be like 2 tasks accomplished. One is conference paper, and then we went to
whatever you say, it is one of the good statement, right? Majority of the abroad university, the professors are doing the same task. I hope you are aware the good conference like CVPR, ECCV, ICCV, right? Then NIPS, So the basics idea, whatever you supposed to expect from your research, the basics idea are going to represent in the conference, and detailed result is going to be published of the same work in a journal. Right? It happens, and this rightly said, Parth, right?
Sir, because I know some details about the conference paper. Many professors have discussed with us that before also going for the conference paper, we will have to do lot of scrutinization. You know, all the committee will give us some suggestions and that, and it will be very much helpful for our further research. So you know, our research will become more mature if we follow this roadmap.
Yeah, of course, that is right. Any other thing? Okay. So here I'm ending the meeting.
હેલો સર
Yes.
મિનિમમ અમે ધારો કે અમે કોઈ ટોપિક લીધો એ થોડો નાનો છે પણ એનું રિસર્ચ પેપર નાનું બને છે તો મિનિમમ કેટલા પેજનું હોય તો બરાબર છે કહેવાય એમ.
Generally, I used to teach students 4 plus 2 plus 1. So 4 means, you know, the write-up. 2 pages are images and graphs and tables and figures and all. And 1 page is for references. So I'm considering as a 12 size font times New Roman. So, you know, 4 plus 2 plus 1. So ultimately it is 7 pages. So this is the minimum, because you need to convert this, you know, your draft paper into the IEEE format or Springer format. So IEEE format, you know, 10 times New Roman, 10 size times New Roman. So when you are going to convert this 7 page, it will be converted into the only 4 page, because a double column 10 size. Okay, so this is a minimum requirement, 4 plus 2 plus 1. Beyond that, it is up to you.
ઓકે સર.
એન્ડ સર બીજો ક્વેશ્ચન હતો સર, બીજા કોઈ ફેકલ્ટી ઓલરેડી રિસર્ચ પર કામ કરતા હોય અને સર એની અંદર આપણે ઇન્ક્લુડ કરીએ તો સર એ ગણાય?
હા, ગણાય ને.
ઓકે, એટલે સર પર્ટિક્યુલર આપણા ડિપાર્ટમેન્ટના સર ફેકલ્ટી નથી એટલે બીજા ડિપાર્ટમેન્ટના છે, તો એવી રીતે ચાલે ને?
But what I am asking currently as a machine learning pedagogy, so if the domain is going to change, so it may not work. So let me clear first thing, na.
ઓકે સર, હું મશીન લર્નિંગની જ વાત કરું છું ને, મશીન લર્નિંગના પર્ટિક્યુલર ડોમેન પર.
Ha, that is fine. Okay, so but before publishing your paper, you have to scrutinize from me. Okay, you have to take approval from me. So this is the paper, you just mail me, and this is what my idea, and I want to publish a paper.
ઓકે સર.
So I'll send a green signal, right? Or maybe a changes, or maybe, you know, the editing. So you just understand why I'm saying that, you know, I generally be a reviewer of so many conferences and Scopus or maybe elsewhere conferences and journals, and I generally review at least, you know, within a week 1 or 2 paper of not student but from you know, the global. I'm telling to you. So if I'll put my perspective in your paper, so definitely there would be some changes. Okay, but I'll give you the, you know, the precise changes, and it will be help you to select your paper as soon as possible, right? Which will help you in your recommendation letter. Otherwise, what happen? You wrote your draft, and then you have directly submitted, or maybe you have taken 1 or 2 inputs from the other faculties, and it may be possible that, you know, that conference perspective is not going to be served, and there are a lot of changes is being given. Again, you will take 1 or 2 months, or maybe 15 days or 20 days, or maybe 1 month to resolve it out, and it unnecessary, it will getting delay. So before sending the paper, if you can complete, you know, the things very well in advance, then it will be good for you. So such kind of review time you can reduce, okay, from their external publisher. So that, you know, I told Par Singh sir to share one of the form, and I think he has shared. and I hope you have filled those form, right?
Yes, sir, we filled that.
Okay, so I'll see to it now, and then I'll also discuss. And as I told you that I want one lecture to discuss such things. I'll also tell very small tricks and very efficient and smart tricks to make a paper as a BTech student. Okay, so then it is up to you that whether you need to utilize such tricks and be a fast, or you want to do hardcore work and you want to complete it within 6 months. So then it's up to you. But I'll just tell you to how to make a smoothing out this process. That is in my hand. So I'll guide you each and every students.
Okay, sir.
Okay, and I'll check all the drafts thoroughly, and then you are supposed to publish. Otherwise, not. Okay, so I'll take one of the lectures. So I'll let you know when and where. So here I'm ending the meeting. Okay. Okay. Bye.
Bye, sir.